Welcome to yet another episode of the Practical SQL Server HA DR show. My name is Edwin Sarmiento, and welcome to the show. If you're joining in for the very first time, the goal of the Practical SQL Server HA DR show is to provide insights, lessons, tips and tricks, best practices, or sometimes not so best practices, mistakes made, so you don't have to make them, regarding anything SQL Server high availability and or disaster recovery solution. But instead of just focusing on the technical aspect, I focus on the non-technical aspect of high availability and disaster recovery, because most of the time, we technical professionals would rather focus on how do we do this, or the strategy and the technical details of the implementation, without realizing that's just one piece of the entire puzzle. And from working with customers for the past 20 plus years now, and I was in that predicament way back when I was starting out in my career, focusing more on the technical aspect of an implementation, whether that's, hey, let's implement an always-on availability groups, or let's use log shipping, or let's use a combination of full differential or transaction logback. It forces me to just be so narrowly focused on the tech without realizing there's a much bigger picture, like the impact of what I'm working on, or the business impact of this solution if it doesn't work, or the different people involved. And that's what this whole show is about, and also making sure that it's more than just implementing the technical solution. It's also making it practical and actionable. Because what good are these lessons if, well, we're not taking action on them? All right, this is part 4 of the series on inherited disasters. I started off with part 1, introducing the context of the series, where you're new in the company, you're starting out, it's your first couple of weeks, and you start to realize the entire SQL Server environment is a mess, and now you're responsible for it. I broke it down into the 3 categories, or three buckets in what I call the A.R.T framework, right? The A.R.T framework with A, every letter of the A.R.T framework stands for something. A for assessment. You're assessing for risk, compliance, security, and high availability. And then R stands for the 4 R's, where you're you're rating the risks, and you're also requesting for the reduction of those risks. This episode number 4, talks about what I call the 3 T's. By now you could probably tell I like using either acronyms or groups of 3s or 4s because it's easy to remember, right? And you know how it is with so much information on the internet. We don't need more information. We want actionable items, actionable insights, where we can take those lessons and, again, run with them, do something about it, rather than, you know, collecting as much information as possible. So this episode focused on the letter T in the A.R.T framework, and I also broke it down into 3 T's. 3 T's stand for, grab your pen and paper, start taking notes. Let's get down into the details of what those 3 T's are. First T is to tweak. I started off this entire series where if you're brand new in the environment, you've inherited it, now it's your responsibility. It's easy for us to jump at technical professionals, that is. I'm not excluding myself. It's easy for us to jump in and start making modifications, make drastic changes. It's normal because we want to feel like, yeah, we're saving the world and we're making this entire environment as stable as it is, reliable, highly available, because that's our job. But I started off with, please do not make modifications just yet, especially when you're dealing with high availability and or disaster recovery solutions. Mainly because you do not want to add more risk to an already messy environment. Like, you don't know, and that's where the letter A come in, where you're doing your assessment. Part of what you've taken from that assessment, the results of the assessment, is what you use to start rating and itemizing, listing all of the things that you've uncovered from the assessment, and then you create action plans on how to, letter T, tweak the environment until, of course, you end up in a situation where it's exactly how you want it to. But the reason I started off with tweak is tweak stands for incremental improvements, small changes, not big changes. Okay, you start with low-hanging fruits, and of course, based on the letter R, where you're rating the risks. If it is immediate, if it's urgent, you know for a fact that you have high risk, then make sure that you're requesting for reducing that risk immediately. Now, of course, there will be times when you can't just do that, and so you would have to request for a maintenance window, have to request for approval from stakeholders. But once you get the approval, you start making minor, and I say minor modifications. And again, it's easy. Learned this the hard way, but it's easy for us to again target the bigger improvements, bigger changes, because they're visible changes. But here's what I've observed and I've noticed in the field, and even as humans, we don't like change. And because we don't like change, we avoid change at all costs. Well, major change that is. But if we make minor changes in the way we do things and make that consistent, next thing you know, those smaller changes snowball and become a big change. That's why this is very important. You start with making incremental improvements, small improvements. Let's take this down into more tactical approach or strategy-based approach. In high availability and disaster recovery, one of the things that I look at in a SQL Server environment is virtual log files. The amount of virtual log files inside a database transaction log file, because not only will it affect restore and recovery when you're recovering your databases from backups, it will also affect your failover time. Say, for instance, you're dealing with either a failover clustered instance or an availability group. Upon failover, SQL Server will have to read a transaction log file for, let's use failover clustered instances as an example, where a complete restart of the SQL Server service has to occur on the standby node. SQL Server will have to read the transaction log record or transaction log file, look at transaction log records. Now, SQL Server looks at it in terms of virtual log files, like small buckets inside a transaction. The more buckets that SQL Server has to read, the longer it will take for SQL Server to run, restore, and recovery. That's why in SQL Server 2008, Service Pack 2, if I'm not mistaken, and SQL Server 2012, Microsoft started writing error messages or messages in the SQL Server error log telling you there's X amount of virtual log files in this particular database. Back then it was 10,000, lowered it down to 1,000. Of course, it's all dependent on how large your virtual log files are, how large your databases are, the amount of transaction log records generated. But the idea behind that is because SQL Server has to read transaction log records inside your transaction log file, the more virtual log files that SQL Server has to read, the longer it will take for restore and recovery to happen. Restore and recovery if you're doing backups, recovery if you're you're restarting SQL Server or failing over an availability group or failover clustered instance. But that's a small change that I look at. Evaluating the virtual log file and look at, is this too many? Is this too few? And a minor tweak is simply, if it's too many, reduce the number of virtual log files and shrink that. Now, of course, that's just one example. What about, hey, our transaction log file has grown big. My transaction log file is about 150 gigabytes, and my database is roughly around 100 gigabytes. So my transaction log file ended up becoming larger than my data file. Small tweak, shrink. Of course, you don't do that in a normal business day, you request for a maintenance window. That way, when you're doing the shrinking, it does not affect your day-to-day database operations. Okay, again, taking it into a more tactical approach, evaluating the environment, looking at, hey, these are things that would impact our availability, okay, recoverability for the database. Or in cases where, hey, you saw the sysadmin account, the SA account, is being used on everything. Security-wise, we're not supposed to be using the SA login. Of course, that's going to be a more drastic approach because some application vendors still use the sysadmin or SA login. So you start making minor modifications. And then part of how you make these modifications is you test, you measure the effects. Because there's no point in trying to make modifications if those modifications are not going to make help improve the system or stabilize the system, right? You have to have a before and after. An example of this, and like I said, we'll start off with kind of like the high-level idea, and then we'll make it more tactical. An example of this is realizing that your backups are taking longer than necessary. What do I mean by longer than necessary? Well, in the beginning, you realized on average it was running around less than 30 minutes for the entire SQL Server instance to complete the backups, and now it's taking like 4 hours. 4 hours, 30 minutes versus 4 hours. If it was 45 minutes, understandable. But from 30 minutes to now 4 hours, you start making modifications and then tweak and then test. Okay, one of the customers that I worked on, or cases that I worked on about 2 years ago, had this very example. They were running on all-flash array, VMware for their entire infrastructure, and SQL Server running on VMware as virtual machines. And when they started configuring the backup strategies, they scheduled it at around 11 p.m. Their time zone, because it's not a 24/7 operation. What used to take about 30 minutes to complete the backup for everything, and we're not just talking about one SQL Server instance with 20, 30 databases. We're talking about like 16 SQL Server instances with on average 20 to 30 plus databases per instance. What used to take about 30 to 45 minutes now has taken 4 hours. That's exactly where I got the example from. When we looked at, there were a couple of reasons or possible causes for that. One of which was their all-flash array probably could not handle the workload. And I say probably because we haven't even dug into the details of troubleshooting what is causing the problem. So that was one theory, one of my theories. The storage subsystem could not handle this. And so we started measuring how long it takes. About 3 weeks ago, how long it takes, or how long it took for a full database backup to complete across all their environment. Took, again, 30 minutes, all at the same time. Okay? And because we have the numbers in place to determine that this used to take 30 to 45 minutes, now it's taking 4 hours, what could possibly cause that? We started looking at the backup history tables inside SQL Server, and they all started at the same time. And of course, it's kind of challenging when you're looking at 16 plus SQL Server instances. So you have to gather all of that information, look at it in a spreadsheet, look at some anomalies in the data. And true indeed that the all-flash array could not handle the workload. So I asked, well, so what started happening? Turns out that in addition to them running SQL Server database backups, they were also running virtual machine backups all at the same time at 11 p.m. So in the past, they had the virtual machine backups running on a different time. Okay. of course, the database administrators are not talking to the system and the VM admins, and so they all ended up scheduling all of these things. And I did say minor change, like tweak, because immediately the instinct would be, why don't we just upgrade our all-flash array? That's a major change. That's not a minor change, other than the fact that it will be very expensive. They would have to call their hardware vendor, ask for availability, submit a purchase order, get it delivered, reattach or attach the new. It's a long process, other than the fact that it's also very expensive and it's a major change. And so realizing that the all-flash array could not handle the workload simultaneously, one of the things that I recommended was, why don't we stagger both the database backups and the VM backups? That's one idea. And what I mean by stagger is, don't schedule everything on at 11 p.m. Why not schedule some at 9 p.m., then some at 9:30, then some at 10, then some at 10:30, just to spread the workload within certain time frames, while also meeting your recovery point, recovery time objectives, and service load agreements. It's easier to just schedule everything in one shot and say, I want to run this at 10 p.m. or at 11 p.m. It's easy. But other than the fact that, again, VM admins were not communicating with the database administrators and implementing their own strategies and schedules, at the same time coinciding with everything else, a simple communication might have resolved that issue. Or just having conversations between the team could probably have prevented that from happening. But that simple example, okay, we changed the schedule of the SQL Server instances. It's just a matter of modifying the SQL Server agent jobs running the backups. That was it. Spread it across times between 9 p.m. to 11 p.m., all 16 SQL Server. They all ran normally because now there's no VM backup running simultaneously, putting a lot of work, a lot of load on the storage subsystem that's blocking SQL Server as well. So it's a simple tweak, okay? Because again, it's tempting for us technical professionals to start looking at the bigger change first, versus let's do some minor changes here and there and see, based on this, test, measure the effects. You have the before and after, and you don't just want to be guessing for this. Use data. As data professionals, of course, that's something that we're very, very comfortable with. In that example, we use the backup history with records of how long it took for a full database backup to complete. We had that, and then at the end of the analysis, we realized, hey, either the VM admins don't run everything at the same time, and also stagger that. Of course, it's a combined effort. We started off with a database. Okay, we started off scheduled different times for all the SQL Server databases across 16 different instances. But it didn't stop there. We also told the VM admins, why don't you stagger the backups and not just run everything, taking backups of all the VMs at the same time? So they also did that after we've done our part. And lo and behold, went back to like 30 to 45 minutes for the database. And for the VMs, of course, it also helped them because now their storage subsystem can handle the workload. But it's a simple tweak, okay? Going back there, it's a simple improvement, incremental improvement, but we have the before and after numbers that told us we made progress. Okay, so we tweak, make major, minor changes, we test, okay? And part of that also, like the example of reducing the virtual log files, test. How long did it take before when X number of virtual log files were available to failover, and then how long did it take now that we've reduced the number of virtual log files, how long did it take for that to failover? Measure, use data, and use numbers to prove that what you did actually mattered. It's not enough to say, I did this and this is what happened. Well, sure, but you gotta have numbers to back you up and back up your claim. Okay, so I did say 3 T's. First is to tweak and then to test. Not all tests will be successful, right? Not all tests will be successful. That's why you also have to do minor changes, small tweaks, because you also do not want to cause problems as you're making these changes. Like for instance, one customer that I worked on had massively large database and they could not run DBCC check DB in one go because it's taking forever to run DBCC check DB. So we staggered the checks. But in addition to staggering the checks, we also do not want DBCC check DB to be interfering with normal business operations in case it went beyond the maintenance window. So part of that is, okay, why don't we break down check DB to check table, check alloc, and then measure the amount of time it takes, and then identify critical tables, and then schedule accordingly, right? Then measure, because again, you do not want to have that minor change all of a sudden causing more issues. And that's why I said not all tests could be successful. And that's also one of the reasons why I call it a test. You have a theory, you test your theory, come up with whether it is successful or not. You validated your theory, but once you haven't succeeded with the test, meaning you tried a test, didn't work, you iterate. Change whatever you need to change for that particular test, for that tweak that you're trying to do. But once you're satisfied, once you've successfully validated your test, it's now time to do what I call transform. I break the transformation down into 4 as well. Okay, because transformation does not happen overnight. It happens over a series of activities and events happening. I start off with stabilize. Okay, stabilization means you've identified the risk based on the assessment. You've reduced the risk by tweaking the environment. You're successful with the results of that test by making those modifications. Now you apply it to other environments. Okay, so for example, I'll use the virtual log files example. It was successful for one database. Let's try and do it for other databases. And again, it's tempting. Hey, it happened on one database. I want to do it immediately on all of the databases. Nope. Do it on one database first. Test and make sure that you're happy and you're satisfied with the results of that test. Once you're satisfied, you now have something that you can use to replicate across the environment. Okay, so you stabilize, you use that information, apply it on another database. In the case of that SQL Server backup, you have now that framework, it worked, that tweak worked on that SQL Server instance. Let's apply it on another SQL Server instance, and then another. You stabilize first, and then you standardize. Okay, there's no point in standardizing if it's not stable. That's why I break the transformation down into sequence. You have to stabilize first, not standardize. And this is a little bit more challenging, especially in larger organizations where the default has been, let's standardize. This is how we do things. This is how we implement X or the configuration setting. This is how we do it. But if it's not stable on one environment, if it's not what you wanted as far as making modifications and testing and the results, if you're not satisfied with the results, there's no point in standardizing. Okay, so you have to stabilize first. Okay, start with stabilizing. Document that item that you implemented, that change that you implemented, and once you're happy, it's stable, you make it a part of your standard. An example of this is the build guide or the build process for SQL Server instances. That's also one of the reasons why in public cloud environments, you see this concept of we have a golden image. Let's say you want to deploy SQL Server virtual machine on AWS. They have a golden image of what version of Windows, what version of SQL Server, and everyone who would deploy that virtual machine with SQL Server will have those settings. Some tweaks might mean, oh, I'll add more vCPUs, but or add more virtual memory, but the overall setup and the overall configuration remains the same. That's standardizing. But the only way they could standardize was to first stabilize, grabbing best practices from Microsoft, grabbing AWS's internal best practice, incorporating them into VMs, and creating a virtual machine template. Okay, same thing with private cloud implementations. Here's a virtual machine template. This is the number of virtual CPU cores. This is the number of RAM. This is how the disks are partitioned. This is how SQL Server is installed. Anybody who would request a brand new virtual machine with SQL Server installed, this is how it looks like. But they could only standardize if it's stable. There's no point in, I'll use this example, whenever you're automating, because that's also part of automation and standardizing. When you're automating, imagine trying to deploy a default SQL Server instance with 4 TempDB data files. Well, we are standardizing in 4 TempDB data files. Well, true, but the only reason why we want multiple TempDB data files is we don't want contention on data file. That's the only reason, and the contention could come from the lack of virtual CPU cores. But what if you have more than enough virtual CPU cores, or more than enough physical CPU cores to not even have contention that you only need like 1 or 2 TempDB data files? And this is where stabilization or stabilizing something has to come first before you standardize. But it's not just enough for you to stabilize before you standardize. You also have to secure things. There's no point in trying to standardize something if it's not secure. Okay? Again, you incorporated or you've inherited rather an environment that is in a total chaos, total mess. There's a lot of risk, and we're not just talking about high availability and disaster recovery risks. We're also looking at security and compliance risks. So evaluating that, you incorporate those changes. Like for instance, yeah, we're deploying a brand new SQL Server instance. We have to check, are specific port numbers that are not necessary, are they open? Is the SQL Server browser service necessary? One example that I could think of is the SQL Server Customer Experience something program, the CEIP program that came by default when you install SQL Server 2016 or 2017 and higher. I don't want that in my installation. I only want the SQL Server server or service and the SQL Server agent service. That's it. But every time you install the SQL Server failover cluster instance, it came with it. So totally up to you if you want to standardize on, I don't want this, I will remove it from my installation. I don't want to incorporate it or include it. So part of the security part, or part of the stabilizing before you standardize, is also securing. And so you either remove it from the installation and make it part of your standard build process. And finally, within the transform is scale. You've taken one change, you've used that change, you measured before and after, you're happy with it, you're satisfied with the test, you've made it a part of your build, a part of your operational process. Now it's time to scale it up. Okay? You stabilize and you secure, and then you standardize. And once you're happy, that's the part where you have to scale. This is the secret to not just taking ownership of an environment that you felt like it's a complete mess, but this is also the secret to making sure that you're not burning yourself out working because you have to do a ton of firefighting. Okay, you have, part of it is the reason why you're standardizing is to make your life easy. Right? If somebody says, I want to build a SQL Server instance, I want the database files to be like this, I want the database files to start at X megabytes or X gigabyte data file size and X gigabyte transaction log. Everything's standard. That way, your automation scripts are standard, and the way you start automating, or when you start automating, you can now run at scale. So your monitoring tools are now looking at a standard setting. It's also one of the reasons why a lot of public cloud providers, or even large organizations implementing their own private cloud infrastructures, they have this, what is called the tiered infrastructure. Tier 1, the gold standard. This is how we treat our mission critical environments. This is how everything's configured. And then they have Tier 2, or the silver tier, where maybe not so mission critical, but it supports the mission critical infrastructure. And this is how we build the virtual machines, the network, the apps, the databases, everything. And then there's the bronze, or the Tier 3 infrastructure. They're not as mission critical. They're not as important, but they're needed within the organization. This is how we build them, so that anytime you're deploying a new application, you categorize them according to, is this gold, is this silver, is this bronze, or Tier 1, Tier 2, or Tier 3, and this is how we build them. This is how we will monitor them. This is how we will support them. This is how we respond to issues. The T, the transform, becomes a part of your operational processes, making it more efficient. That's the goal. And with scale, you can now do more, accomplish more without putting in a lot of work. And I've seen, again, so many database administrators and systems and tech professionals in general, where because they do not look at it from a standardized, stabilized, and secure environment, it's very difficult to scale. And we're not just looking at infrastructure, we're looking at you, the way you scale you, because there's only one you. And the joke that I tell my customers is, well, I might be a high availability expert, but I'm not highly available. Like my sleep, I eat, I live life, I do things outside of work. And so in order for you to scale, you have to create systems and processes. Part of it is standardization, so that when an increase in the demand for your work hours, it's easier to do the work, it's easier to do more without you actually putting in the work. It's as simple as, I'll run a script because everything's standardized, everything's stabilized and secure. I can run a script and then scale. Like, let's rebuild this entire environment from start to finish. All you have to do is pass parameter values, run a script, because you've stabilized, you've standardized, you secured it, and now it's easy to scale. That's also the beauty of why a lot of customers are moving to the cloud. Because now, with a click of a button or a notebook that you run, it builds an entire infrastructure, running infrastructure as code or standardizing across different environments. This is the power of the A.R.T framework, okay? Especially when you're inheriting environments that you feel like it's a total mess. How do you even start? The worst way to start is make changes immediately. That's the worst way to start, okay? Because again, you don't want to introduce more risk. You want to reduce the risk, so that you can slowly make modifications. And the key here is really patience. You got to be very patient, because if you've worked with environments like this before, you kind of have an idea. Like, this is how I want it to look like, but it's not there yet. And so you get to be a little bit impatient. That's why the key here is patience and using data to your advantage. This is how it looked like before. This was the behavior before. We've implemented the change. Now this is how it looked like. And now you can use that as the basis for building how your standards would look like, so that you can scale. And also not burn yourself out working. This wraps up the 4-part series on inherited disasters, where you are responsible for an environment that you did not build, your first couple of weeks on the job, and realizing it's a complete mess. Now it's your responsibility. what do you do with it? We wrapped it up with the the 3 T's in the A.R.T framework, where you start making modifications, tweaking, testing, and eventually transforming the entire environment. That's about it for this episode of the Practical SQL Server HA DR show. I'm still thinking of another series where I can pick one topic and start diving deep and come up with actionable items based on those topics. If you need help with anything SQL Server high availability and or disaster recovery, be it in the process of designing, implementing, managing, or supporting or troubleshooting, reach out, use that link on the screen, schedule a strategy session. This will lead you to my calendar page where you can pick and choose the time that works for you. In the call, we would do the letter A, the assessment. We'll assess what kinds of challenges that you have, the problems that you experience, and we will assess what kinds of solutions that you need. Whether that's something where you need to evaluate an existing high availability solution, or you already have it, but you're not capable of managing it. And then part of that is coming up with a strategy on how to achieve those goals and meet those objectives as part of the assessment. Okay, use that link on the screen, schedule a strategy session, and more than happy to help in any way I can. That is about it for this week's episode of the Practical SQL Server HADR show. Enjoy the rest of your weekend. I will see you again in the next episode.